Good morning, everyone. Good evening, folks in India. So, this week, as part of weekly system design sessions, we are going to have a mock interview between Aseem and Abhishek. Aseem will be the interviewer, and Abhishek will be the interviewee. And we'll give about like 45 to with plus or minus 10 minutes. So, and maybe after that we can discuss the feedback and stuff. For folks who are new, this is how it runs. Like we'll be mostly listeners and be in the chat while Aseem interviews Abhishek, and yeah, and we can circle back after about 50 minutes and discuss how we can about the feedback and all other stuff. Okay, with this I'll give forum to Aseem and Abhishek.
Yeah, hey, thanks, Naga, for the intro. So, hey, Abhishek, let's get started.
Yes, Aseem, sure.
Okay, so Abhishek, today we want to design a system like a API rate limiter.
API rate limiter.
Mhm.
Okay, what is the API?
So basically, if you're aware of any service, today there's a world of microservices. We have a lot of services, and there could be service where like people are calling, but I want some kind of a rate limiter or a throttling where I can do something based on the number of requests at high level.
So we have some API and we want to throttle the number of requests someone can make to my API, right?
And this could be right now could be one API, but it could be a generic solution. I can take it to any API.
Okay, right. And okay, so like what, so who are we going to throttle? Is it like we have our internal system is calling our APIs, or is it like some partners? Like let's say I'm Google Maps or something, I'm giving my APIs to businesses and all, or is it like a general user? What's the...
Yeah, so good question. So it could be right now anybody. It could be a service or my partner team calling this API, or it could be like integration tests who are calling this API. It could be some anonymous user who is calling this API. It could be like a logged in user who could be calling this API. So pretty much wide open, like anybody can, or it's a public API. People can call anonymously also. It can call with some login with the information also.
Okay, so then you are saying that if it's anonymous also, we don't have any ID and we are just getting a request. So then is it like we don't want to overload our system? So if our system, let's say, can handle, let's say 500 requests per second. So I'm just saying that if my request go over 500 requests per second, I won't allow any other request to enter my system. Is that what I'm saying?
Yeah,
Because
so,
with this,
yeah.
I'm not able to distinguish anyone.
So still you can distinguish, but right now, high level it could be 500 requests per second. But but it's like how you design. Is it something you can't distinguish?
Yes, so I mean, I should know the information, right? That like, am I So one is a very generic design that I'm just throttling a request. At the request level, I'm just throttling. Other is I'm throttling at that particular same user or that particular customer, that because I have shared resources and my shared resources for my API are accessed by multiple people. I don't want one person to overuse my shared resources, and that's why I'm only throttling like throttling someone who is misusing and making multiple requests. So that is one design where I'm throttling based on then user ID or some identifier for that request, that if the same person is making multiple requests,
Okay. So for simplicity's sake, let's say like remove anonymous user from the equation, and we will have some kind of identity.
So then we have some ID, and for that particular ID, we are allowing some number of requests per second, and he's not allowed that. Okay. And so what numbers are we allowing to have?
So we can start with any simple numbers for now. It could be like 3 requests per second, or and okay. So I've so and it could be, it again can depend. If I have a premium user, I want to give it more flexibility.
Oh, okay. So then, nice. Okay. So then we have this. Okay. So then we have some, this kind, I'm just writing here that this is the ID,
Mm-hmm.
and this is the limit, and it's variable, it's not fixed. So for user 1, I could have limit 3.
Mm-hmm.
For some other user, which is premium user, I could
Mm-hmm.
have limit 10, right? So I have to maintain this information.
Yeah.
Okay. Okay. And also probably you are saying this limit could also depend on API, right? That this API, like suppose if it's kind of a read-only API,
Mm-hmm.
probably I can have more limits. And if it's a write, like, or if it's some write-heavy API or some API which
For
do
now, I think let's not
do
get
API
into this distinguish between read and write. Let's be stay at the user level.
at the user level. Okay, got it. Okay. And so like I would have to store this information somewhere, right? So just to estimate like how many IDs, how many distinct IDs we can have, so that I know that whether this thing can be stored in one place or what. Do we have some idea about that?
So think in that way, I could have uh, uh, 1 billion users, and at any time I can get like 1 million requests.
So we have 1 million distinct users. Is that what
So
you're
I have 10 billion users. Oh, sorry, uh, okay, we have 10 million users, but at any point of time, 1 million users are active.
okay? And active per second is 1 million user.
Mhm.
Okay. So nice. Okay, 1/10 of the users are active always.
But are you clear like why we are doing this?
Why we are doing what?
Rate limiter, why we are doing this? Are you clear on that?
Uh, so I know. So up till now, I have come to know that we have users, and we don't want to make. We don't want to allow one user to overuse my resources. So based on how much he has paid or how much quota we have assigned to him, I will only allow him that many requests, and I won't let him go beyond that. Right?
Okay, okay,
Is,
okay.
is there anything else I'm missing?
Uh, I think we can go ahead.
Okay, okay. Yeah, okay. So, hmm, so this is okay. This is my like kind of, so my functional requirement is that
Mm-hmm.
given a request, right?
Mm-hmm.
And I have to tell whether it is allowed or not. So basically, I will say allowed or not, bool is allowed,
Mm-hmm.
and I will be given a user ID, right? And for this user ID, timestamp will be inbuilt, but this for this user ID, can I allow him to serve the request or not, right? I have to kind of, my overall API limiter should have this API,
Mm-hmm.
right? And then, yeah, so I think this is the main functionality we are
Mm-hmm.
expecting. Uh, so the non-functional requirements which I can think of is, so because whatever system I have, this API system,
Mm-hmm.
I am just my request will first go to API limiter before actually hitting my actual service. So I have to make sure that this is fast. I should not add more latency, that this is taking more time to deal with.
Yeah.
Right? It should be fast. So I mean low latency.
Mm-hmm.
Uh, I yeah, I'm not sure about what is the availability and consistency we want. If my API limiter service itself is not available, is that okay? I think
So basically, what do you think? Would that be okay scenario?
I think if sometimes it's not available, it's fine. I can let that request. Yeah, that depends. Like, do I have like hard limits that I cannot? I mean, it depends. Like, if I am serving a service like I'm blocking credit card transactions or something more than 3, then I should probably have uh, a hard limit that more than 3 is not allowed.
Okay.
But if it is a service where if my goal is that I just don't want my resources to be get overused by one particular user, then I don't have a hard limit. So if my API limiter system is unavailable, I can assume that I can let that request pass through and I will serve the request.
Would that be a good user uh, use case for the my end user? So I have a premium user, and some reason his or her request get denied or neglected because some other user took my quota. So do you think would that be a good user experience?
It won't, but I was just wondering that I mean if the system is okay, so we have to make it highly available. Is that what you're saying?
Yeah, it should be highly available, and I think it should be highly reliable also.
Yeah, I think we try. Okay, so it should be highly available. Then if it is highly available, then we cannot make it. But then the problem is if it is highly available, we cannot make it consistent, right? We cannot make it consistent. It will be eventually consistent, and then in that case also, so
How can you say it is eventually consistent if it is highly available?
because if multiple requests are coming and I want to actually store them, then I have two choices. Either I can have some stale information about that data, right? And so in that case, my data is eventually consistent. I will make you my data always available, but I'm not sure that the data which I have available is actually
No, here we are
consistent.
not exposing the data to somebody. Here the
Yeah,
system is taking a decision. So if system can process it really fast, then availability will also be there. But there could be some error rate on the reliability, but I don't want really high. So in this case, let's say if you are using a stale data, again the problem would lie there. What is your eventually consistency look like? If it's like a minute, 10
yeah.
minutes, 15 minutes, then that means I'm taking wrong decisions, and I don't want that. So when I say highly available, reliability can take a hit, but it should not take that much. Like it should be like some error rate, but I don't want really high error rate there. But if you think like right now to go ahead with highly available and eventual consistent, let's go with that.
Okay. Okay, sure.
But I told my concern that I don't want to take wrong decisions.
But
But
with
if I take a
I'm just saying that
eventually
with
consistent,
eventual consistent model also you can take wrong decision because you don't have the latest snapshot of what like so in your data you will be calculating how many requests you have got for this user, right? And if that data is not accurate, you might think that you have only served 2 requests,
Mhm.
but actually you would have served 3 or 4 requests.
Mhm.
So I think, yeah, one thing would have to be compromised, but okay, it's fine. let's like move
And,
ahead.
I think we are jumping to the conclusion really in the start of the design.
Okay, sure.
Right now, I told you my requirements, but in your design, it can change. But my requirement is highly available, and I should get right results.
Eventual. Okay, got it. Okay.
Eventual consistency there or not there, it doesn't matter to me. My
Okay.
requirement is highly available and with less error rate.
Okay, got it. Okay. So yeah, and less error rate. Let me write that down. Okay. Okay, cool. Okay. So so this are my requirements. So first I'm thinking about this based on the above requirements. So I have what data I need to store. So I have this ID, I have this limits,
Mhm.
and probably I will just,
Right now, are you planning to show me like some kind of high level design, or you want? So which component you are picking?
yeah, I'm just quickly going over what data I need to store, and uh,
Okay.
then
Mhm.
we can go at high level design.
Okay, sounds good.
So we need to store this ID and limit, right? This is
Mhm.
what we are storing. And this, I just want to calculate how much data we are storing so that I can, so if ID is of 8 bytes and if this limit is of 4 bytes, so we have total 12 bytes, right? So
Mhm.
12 bytes. And then you are saying we have 10 million users. So 10 into power 6 bytes. So which is bytes, uh, kilobyte, megabyte. So 120 megabytes of data, right?
Mhm.
So this 120, okay. So then this actually this information I can store on one machine, that how many, uh, what's the limit for each. Okay. And somewhere I would have to also store like what is the current count. Okay. But that is another separate topic. Okay. So I'm just going on a high level design, and I want to see that where my API limiter service will actually live in the system. And
Mhm.
then we can see. So let's say we have multiple clients making requests to my service. I think my service will have first some load balancer, and then from the load balancer, so this is my application server, which is actually serving my request, right? So this is where my API code lives. This is the machine where my API code lives. So
Mhm.
load balancer will be giving these requests to this applications server. And what we are trying to do is we are building a service which will throttle
Mhm.
throttle the request to these application servers, right? So,
Mhm.
okay. So now where should my throttling service live? Uh, so this is the, so one thing I can do is at the load balancer level itself, I can like okay, so it depends. If let's say load balancer is a separate team application, this
Mhm.
application service is a different team, and I am the owner of application service, I don't have control on this. I would have to write some logic in the application service, or I will have to create a separate service for API limit. But is it possible that I can modify the load balancer and do something here?
So load balancer is something is typical known for rerouting the request based on the load. I feel that would be like additional responsibility on that, and it may violate the single responsibility principle. So it would be doing additional things, and so what I feel, it should be a separate component. We should not be merged it with the load balancer.
Yeah, I totally agree. Yeah, that yeah, load balancer is not supposed to have this kind of business logic things. So yeah, it should not have it. Okay, so now like one thing I'm thinking is that we can have like a layer over here that even before hitting the application service. This is my API service, API rate limiter service running, which has its own machines and all. First the request goes here and then they will be forwarded. Or other thing is that within my applications,
I'm getting a bit confused with the. Hold on, I'm a bit confused. So you're telling like rate limiter will decide and then read out the request to that machine.
to the application server, yes. Is that
So that means this guy should also be knowing about machine locations.
this guy should also be, yeah, this guy should be knowing about, no, I mean, yeah, so whatever request was going to this application service, right, kind of interject that request. In that request anyways, we will have that information, right, that what machine and where it should hit. So it will just interject that request, and it will, if it has to forward, it will have that information from the request, right, and then it can forward it to the application server.
Okay, go ahead.
So yeah, so that is one. And another thing I was thinking is that in our application server itself, we have this API throttling service. This API throttling service is living in my application service. So once the request hits my application service, then I'm deciding, and if it is above the limit, I don't forward it to my application code, whatever is the application code, which is actually going to read and write from the disk. I don't forward it to that. So there are these two approaches. I don't know yet that which one would be better. So
okay, so
the thing is that having this in within application server, it's simple design. Here you have to create your own infrastructure and your own machines, and I think you are trying to make best use of resources, and here you are first creating more resources probably to actually throttle. So
you're telling like your rate limiting logic will live on the service machine itself.
the service machine itself, yeah, it will be a
Part of the service, or I'm not bit clear with that. So is it part of the service? Are you proposing like it will be a library which would be part, which can service can uh, inherit? Is it something like you are proposing?
Yeah, that's a good question. So if, okay, so this is my application server. Now we're talking about that where will this throttling service live? And let's say I have some my application code, right? This is application code, this is throttling service. So where are these two living? So one is that inside my application code itself, I have written this throttling service that so basically in my application code, I will be doing some expensive operations like some compute or some disk reads and writes, right? So before I'm doing those expensive operations, I am first checking for the throttling service and seeing whether I can forward the request or not, right? One could be this. Other could be, it could be a separate library. It could be a separate process. And so this application service is talking to this separate library via inter-process communication or something and asking, hey, that can I serve this request? If it says yes, then we can serve the request. So I think making it independent is that I can make it more usable. I can use it across different APIs and different application services. Right, but I would have to pay this like if it is inside one component, uh, I would not have to pay the cost of this communication. Here I would have to communicate with another service. Yeah, so yeah.
Okay. So if you're, so let's say you're doing on the application server itself,
This simple
limit the, or I think you propose two things, like either on the application server or it should be a separate component.
This,
so
yeah. Are you talking about this separate component here?
Separate component. So I would like to go deep dive into one of them. Up to you, which one you want to go for.
Okay, so let's, because we were talking about application, having it in application service, let's first see the advantage and disadvantage of having it in applications service. And then, so one thing is that, do I know that will my load balancer is balancing in such a way that the request for same user within that session will hit the same machine, or can they hit different machine?
I think like it's a round robin.
So it can hit different machines. Okay. So okay, I was thinking that if we have within that same machine, then the advantage would be, if the same requests are hitting the same machine, then the advantage uh, would be that for that user, like I don't, so so let's say I have some algorithm which is, for this user I have these many requests, I have 1 per second, right? So
Okay.
this information, I'm if I know that this machine will get only these users, then I need to store the information of only those users in my applications service. But if my requests are spread across multiple machines, then some of the request for that particular user will be on this machine, some request will be on this machine, some will be on this machine, and I have to talk to each other and actually calculate the total.
One thing, it may defeat the purpose of load balancing, because we have a hot user which could be always coming to a machine. So I think that will defeat the purpose of load balancer.
Right. Okay. So right. So then our requests are spread across. Okay. So okay. So then okay. Then these processes have, yeah. So the thing the problem I see with having it in the application services. So this machine already has some. It is already using some CPU and memory and hard disk resources to run its application code. No, but actually, okay, it is using, but my API throttling service will be running before it. Yeah, no, API throttling service will always be running. So this API throttling service will also use some in-memory data structures, some CPU compute and all. So if we have this in the same machine, then we are giving this extra work to this machine.
Okay, let's assume I have a really good resource on the machine. Let's go ahead.
Okay, so that's okay. So then, okay, right. So okay, so now my application service will live over here. Okay, so now we have actually decided that my API throttling service will live on the machine, right? So now let's see, should we go that what will it will actually do on the machine? What will be the process?
Yes, you can deep dive, but I'm okay. Like you told, like you have some mechanism. For now, it's abstraction for me, but it's okay. It can be for now an abstraction, but I would like to go ahead on your more on the scenario, like how you will solve it. Let's say you have some process to find out.
Yeah. Okay. So let's assume we have some process to find out, right? So
like you mentioned, algorithm you will use. If you have something on your top of your mind, it's okay. It's you can share, but if you don't have, that's fine. I can assume like some algorithm you will use and do some calculations.
Okay, so let's first say that we have some algorithm. So then I think on the app, this will happen, right? This is my application service. This is my rate throttling, and this is my application code. So first my request will come here on this machine. It can either come to application code. Application code will talk to rate throttling. It will return whether it can be successful or not. And now if the request cannot be served, then what are we doing? Either we are rejecting the request or we are
Now we are just rejecting the request.
okay.
Let's go ahead.
Yeah, then it's easy. So then the rate throttling will say, okay, you are not allowed to serve any more request.
Mhm.
So then it will return the request. So right, and if it can serve, then it will forward it to application code. Application code will do the processing and return the data.
Okay. How you will manage, like if my request is going to multiple servers, how you will manage that it will get throttled?
Uh, so yes, so each application service is running this rate throttling service, right? So rate throttling service will tell, like, I'm running this rate throttling service on every server. So
Mhm.
so I can talk to that on that particular machine and ask whether it can serve the request or not. Are you asking how am I going to share the data between these, or what?
So my question is like, if I have a throttle limit of 3, and
Mhm.
request goes to different 3 servers,
Mhm.
how the fourth request gets be throttled?
So okay, so then each of these throttling service, whenever a request comes, they will be maintaining the count, and they will also be talking to each other to know what is, like, overall how many requests that user has got in that second. And so they will be talking to each other, and now when a request comes, so each will have the updated information about the user, that the combined how many requests he has served. So then I will just look at my data and tell whether I can serve the request or not.
On top of your mind, do you know like how they can communicate? What kind of protocol you will use? Do
Uh,
you think on your mind? If
right.
not, fine. I can assume again as abstraction, like okay, they will talk to each other.
Uh, yeah, let me think. So one thing is that if I got a request, uh, I can first update it on my system, and then I can send broadcast this count to all the requests. And I am not waiting for them to actually, uh, okay, I'm not waiting for them to actually respond me success. But then I could have some incorrect. If some of the system, if some of my machine does not have did not get the data, they will have some incorrect data. But I think we were okay with some error rate, right?
Mhm.
So yeah, a simple thing could be that I just broadcast it to all the machines, and then every machine will store the updated count. And I'm not also waiting too much, because I will just, if the request comes to my machine, I will first store it in my machine. I will calculate what was based on that information, and then meanwhile I can asynchronously broadcast, right?
Okay, so okay, let's go deep dive into your this rate limiter component, how it will look like. I want to see more, uh, I want to see in some more depth in that. This
That
one you told RT.
Okay, this RT itself, right? Okay, so now let's zoom into this RT. Okay, so basically, first thing I have is I have some uh, business rules kind of thing, that for this user I would have, I have this information stored somewhere, that for this user I'm allowed this many count of request, right? And other thing I want to do is, for every user I want to track how many requests I have got in that second. So we are saying that 3 requests per second. Okay, so I have to track that in every second how many requests that user has got. Okay,
Mhm.
so um, mm,
So where your business rules will live.
where will my business, so how, so see, we calculated that the size of these business rules is 120 MB, right?
Okay.
So I think that these business rules can be, because we have to persist these rules, I will store somewhere on the disk, And also I can load these in the memory of every machines because it's not too much data. So I can load the business rules in memory of each application service. And
And
also,
where they will come? Would they come from some other component or database, or your RT will call database and pull them?
yeah,
Think it
yeah,
through. If I change my rules, what will happen?
yeah. So I mean, so basically I would have some storage service. I will have a separate component uh, which stores these rules, right? So whenever I'm updating the rule, like let's say whenever the user signs up and he's saying what kind of user he is, I will be updating those rules in this database. So here in this database I have this rule book, right? Now when my application service is running, it will periodically go and pull the data from this business rule book and see what are the rules. Sorry, you were saying something?
No, no, no.
Okay, so it will periodically pull, and how frequently it should poll to see if the rules have been updated or not. So
Okay, let's say like you have some way to update your system to have the new rules. Okay, and now you have new rules on your system, like you mentioned, like it would be in the memory. So let's say it is in the memory. So what you will do next?
okay, so now, yeah, so once we initialize this, we have loaded this rules in memory, right? So now, now I would have this logic in my application, in my throttling service, that
Mm-hmm.
uh, you have to calculate the count for this user ID, how many requests you have got within that second,
Okay.
compare it with the allowed business rule count. If it is over that count, then then you are going to reject that
Okay.
request, right?
Mm-hmm. And then you told you will also broadcast something.
And yeah, and then so basically I'm storing some kind of a count. So for this each user,
Mm-hmm.
let's say so this let's say this is the user, this is the count,
Mm-hmm.
and this is the timestamp for which I'm calculating the count. So for this user one, let's say the request come at some x hour, x minute,
Mm-hmm.
x second, and some 30th millisecond.
Okay.
Then I will store the count that, hey, now my count is one. If another request comes within these many minutes, I will just keep on increasing the count here, right? So
Okay.
will become three. Every time I update this count, I will also broadcast it to other machines, and they will also have their data. So basically, my this count could be uh, it could be increased by two services. One is the broadcast messages. One could be the incoming messages could be
We have
broadcast.
a step back. Let's say we have only one server. There is no broadcasting. And
Okay.
with that, what you will do now?
So yeah. So okay.
Is
So now we are
in a
okay.
given time frame, then it will
Yeah, go ahead, Abhishek.
Okay. So yeah. So for this timestamp, I will yeah. So the approach would be that, let's say I get a request, I will first check whether this user ID, I'm basically creating a hash map, which
Mm-hmm.
is user ID,
Mm-hmm.
and uh, so this is my key, and my value will be timestamp and count. That in this timestamp, what is the count I got, right? So
Mm-hmm.
when a request come, I will first see if that it exists in this user ID exists in my hash map or not.
Mm-hmm.
If it does not exist, I will create a new value, this user ID, and I will store this timestamp, whatever this timestamp was, right? And I will set the count to one. Now,
Mm-hmm.
let's say another request come for this user within that same, like within few milliseconds. So,
Mhm.
so because millisecond is not important to me, I will
Mhm.
just store the data up till minute, right?
Mhm.
And now when the next request comes, so I will say, oh, the minute was same. So then it came within that same minute. So I will
Mhm.
increase the count to 2. Then if another request come, I will increase the count to 3. If it is more than the limit, I will reject it. If the timestamp, if now let's say the request came after 5 minutes, then I will see that the timestamp, the difference between this timestamp and this timestamp is greater than 1 minute. So I will store that x y plus 5 time here, and I will reset this to 1, because now for this new time window my count is 1.
Mhm. Okay. So, do you think any issues with that, or
Yeah. Okay. So one thing is that whatever data system I'm using for here, because I'm getting multiple requests, uh, I would have to apply some logs, because if multiple process thinks that it's 1 and they updated it to 2, then it's right. Everyone have to acquire their log. So and sorry, did you okay?
so? Okay, got your log. Apart from that, what do you think? For example, I told like I can. So let's say I have told like I can only get three requests per minute.
Hmm.
So, and all my requests came at the 59th second. So I gave the three. But again, another request after 2 seconds. So within 1 minute, uh, do you think like within a minute it can cater more requests?
Within a minute it can. Okay. So probably, so let's say this is my time and these are my requests. So I am saying that I'm dividing it in seconds. So
Okay,
probably
2 seconds. Okay.
so
And you have
second,
requests per second.
huh?
So you are now dividing on second because earlier you were doing on the minute. So now you're doing on the second. Okay.
Yeah, no, this is second, hour, minute, second. So I'm just storing data up till second,
Okay. In between, I heard like you were talking about minute, but okay, it's okay.
right?
Go on.
So then I think what is happening is that I am whatever request I'm getting for this particular second, I'm storing it here, and I'm checking.
Mhm.
And when this second is passed, I am resetting, and I'm
Mhm.
saying that now the value is 0. Now you start calculating from this point, right?
Mhm.
So the problem that could happen is that a user could, at the end of this second, it could have multiple requests, and at
Mhm.
the beginning of this next second, it could have lot of requests. Then if I see within this 1 second, I have actually breached the threshold. But because I'm resetting my threshold after every second, I won't see this breach, and I will say that the system is okay. So basically, I'm taking this fixed window size, that this is one window, this is second window, this is third window. And but basically within the window, I should be looking past 1 second from that window instead of just looking at the starting point of that window, right?
Okay. Okay. I think I got your gist of your point, and I think it could be improved. But for now, I think I'm good with that. So can you run me through an end-to-end scenario now?
Okay. So now end-to-end scenario goes like this. Should, yeah, okay, let's redraw
And
it.
with that, I also want you to tell me if there are any bottlenecks in the system.
Right. Okay.
So
So
because we are almost at the end, so if you can just help me with end-to-end and the bottlenecks which you think.
right. So this is my load balancer. This is my application service. This is my throttling service here, right?
Mhm.
So the requests come here, and uh, they will do some calculation. They are talking to each other. They are broadcasting. Why I'm not using other colors? Okay. So they are broadcasting and uh, they're broadcasting and they're calculating. So one thing is that this data structure I want to store in memory, right? Where I'm storing the count. Oh, and also I forgot about one more component. This is my business rule. So they are also talking to this business rules service to get the rules, right? Uh, so business rules are stored on disk, and probably this could also cache it here so that it could first get it from cache, and then if it's not in cache, then it can get from here. uh, so uh, so one problem I see is this entire code where I do this calculation, this code lives in memory. And if my machine crashes, then I will lose that information. But I think that is okay because it is just count for that second. So whenever the machine restarts, I can restart and recalculating the counts, right? One, so that is not the problem. uh, the other big thing I see is there is a lot of communication between the services, and if this communication is not reliable, then it's an issue. So I have to I mean, if this communication is fairly reliable, then it's okay. I will have some error rate, but it's okay. But if this communication is highly unreliable, I would have incorrect information. Or also, I don't want that this communication is becoming too much chatty and it is taking a lot of my network bandwidth to actually pass this information.
Okay.
Right.
Okay, and do you think like it looks like you prefer this on the application server rather than have a individual component?
Yeah, I mean, I have not yet thought about how it will look on individual components. So,
So
yeah,
individual component, then all your calculations, everything would be centralized.
it will be it will be centralized. Yes. So, but then I don't know, then that will also become the bottleneck, right? Because if it is, let's say if I have one central machine and if I am getting like 500 million requests, whatever, what the number was, uh, 1 million users, right? So this machine cannot handle 1 million requests per second to calculate whether it should not. So then this machine also needs to do some replication and divide the request and then calculate. I think it will be very similar to this service, only that the load balancer will send some request here. Yeah, I don't see that it will have a big advantage. Basically, we are replicating this kind of system.
We are not replicating. We might be doing a kind of a sharding here. So load balancer is doing and sending requests to any server, but I can still have some kind of a dedicated server for some specific users. So I don't have to replicate. What do you think?
Oh, I'm not saying that. I'm not saying that replication in that way. I'm saying that, like, whatever your system you made for application service, that your requests will be divided among multiple machines, and every machine will store some information about user count, and then they will also be sharing the information.
But
So
why can
your
that machine hold everything about that user?
one machine, if one machine can store also, it's not about the storage, it's about the request, because we are having 1 million requests per second. So anyways, we cannot let one machine like decide everything. So we would have to divide the request to multiple machines, right?
The question is, do you want them to broadcast to each other, or that machine can still handle all the requests for one single entity or user? What do you think?
Again, it depends. If we know that the same requests for a user are coming to same machine, then we can store within that machine and we don't need to broadcast. But if for a particular user ID, the requests are spread across multiple machines, then we would have to talk to each other to find out what is the total count.
Okay,
Right?
fair enough. So I think we are probably at the end now. And you want to, if you have anything on your mind, you can share with me. Otherwise, we can wrap it up.
Yeah.
Okay, so do you think it should be, if it is an individual component, it should be after load balancer or it should be before load balancer?
It will be after load balancer, because load balancer is a lightweight component which just divides the request based on like some IP address or something, right?
Again, whatever, let's assume how much it is lightweight, but we are still unnecessary uh, taking request to a load balancer.
Or you are saying we could have blocked
The whole purpose of this exercise is to bring down unnecessary requests. So, but load balancer would overwhelmed with lot of requests, and most of them will get rejected.
Yes, but the point is, see, the problem is that you are getting 1 million requests per second, right? And you have to do some.
I told like 1 million active users, and 1 million active users, one user can still send 10 requests.
1 million active use. Yeah. No, I'm saying how much is the total request our application is getting? What is the total request?
Yeah.
That is 1 million, right? 1 million per second.
1 million active users, but one user can still send 3 requests, and the fourth request will be throttled.
Yeah, you're talking about user level. I'm saying what is the total overall, if I'm not considering user level, what is the total request?
1 million is the number. Okay.
1 million.
With that.
So I'm saying
let's assume 500k requests are throttled, or let's say 200k requests are throttled.
Yeah. So I was saying a little bit different thing. I'm saying that if I'm getting 1 million requests per second, so without looking at the request, without looking at the user ID or any information, I don't know whether I can throttle these requests or not, right? I have to do some processing on these requests. So now that processing is my cost, right? The cost I have to pay. So I'm saying somewhere we have to do the processing. So the load balancer, what it is doing is that it is a very lightweight component that whatever processing you need to do with these requests, I am dividing it among various machines. Now you can do the processing and then tell me whether these requests can be served or not. I mean, if we have it before load balancer, I think it's not good, because we are first doing the processing and then dividing. But how will we divide? Like, how will we know that how to divide these requests, right?
What kind of processing you're referring? Load balancer, when you told is lightweight component, I don't think it is processing any user metadata or anything.
Exactly. So load balancer will be lightweight. It will just divide, and that's why this API throttling service will be doing that processing. I'm saying that you were asking, right? Why don't we have it before load balancer? So I'm saying we cannot have it load balancer because there is some processing involved for 1 million requests, and that has.
And that's what we wanted.
Right.
Either way, it will happen. Either you put before load balancer or after load balancer.
Okay. I think we cannot put it before load balancer. But yeah, probably
Okay, sounds good. Okay, I think with this we can wrap up our session. And thank you so much, Abhishek, for taking this step and doing this. I really appreciate that.
Yeah, it was great. Thank you so much, Aseem. We had a good discussion.
Okay. Okay, I think the floor is open for the audience now.
Thank you, Aseem, and thank you, Abhishek, for this mock interview. And Aseem, do you have some feedback in mind, or like, do you want us to start discussing on that?
I think either way, I can share my feedback, or probably I can share some of my feedback, and then
Yeah. Then I can. Yeah. Yeah.
hey, Abhishek, can you again share your screen if it is possible? Whatever you are sharing earlier.
Yeah. I think if you can keep it on for a
Yeah,
while, we
sure.
discuss. That will be fine.
Just
And
1 second.
yeah, and good job, Abhishek, and good job, Aseem. And
Thanks.
just take the feedback as constructive. Don't get demotivated or anything. Just to
Yeah.
let you. So it's a very good attempt.
And this is not this would not be targeted feedback. I think anybody from us would do in front of audience would have some restrictions, nervousness, positiveness, and this is like a overall feedback for everybody, including me. So what I found is, Abhishek, are you going to
Yes.
use that?
So this is okay. Yeah. Okay.
Is that a Microsoft whiteboard? Okay.
Yeah.
Okay. Nice.
Okay, thank you. So what I felt like in the start, Abhishek asked good questions like what we are doing and what are the things, why we want this thing, something like that. And he tried to clear his thoughts because API rate limiter, some nobody have heard earlier, could have different notion of what it could be. Even for me also, if I say, oh, API rate limiter, what it is. So he asked questions like what it is, why we are doing, and other things. So which was good. And then he came up with some requirements like how much it would be and other things. But where I asked him that it could be for anonymous users, then he told he could not do something like identifier. But I think it can be still possible using IP address or something. But it's okay. I don't see a huge issue there because again, it could be the API could be called using an API key or something. So it could be viable, but it could be like interviewer could think like okay, IP address could also be option. I mean, the candidate should have thought about that or some other way to find out a unique identifier for an anonymous user. And then I think some things which I felt like it could be good to have to chat about like DDoS attacks. If you know, I'm not saying that it would be a kind of a red flag here, but if you know about DDoS, or you could have also asked like why I'm not scaling my doing a scalability, horizontal scalability or vertical scalability, why I should build this at first place, and who would be my customers. So couple of things which I thought could be asked, but again, it could be good to have. Then I think Abhishek and I have a conflict on the high availability and reliability, and that was a requirement. We don't need to jump into the implementation there yet. While doing a design, if it is not possible, then we can say, okay, this design could not handle the reliability or thing, but that was a requirement. That's just a requirement from my side. If it could not work, that's a separate scenario. So I think we should not spend that much time there while validating the requirement whether it is possible. Because while doing design, I can again come back and say, okay, with this, there would be some marginal rate. Are you fine with that, or you want me to do something different? And then Abhishek brought up two different approaches, which is good. He able to say like, okay, I want to either do in the either separate layer or it could be on the server, so which is good. And then I asked him which one you want to pick. Then he picked one of them, and then we started doing deep dive. And actually, where I don't want him to go, I actually cut down there because I already felt like he has the understanding and information there. I just want to go to some other components. But one other thing which I felt could be different, like a rule manager or something, which I was not so clear till the end, like how that will work exactly, because Abhishek was mentioning about you keeping on the disk and other things, but I knew that he has some component, and if I do some deep dive, he would be able to refine that. So on top of that, and he also spoke about some approach how we'll do broadcasting. So overall, he was able to get along with me. And at the end, I asked him out where he wants to keep that. If it is a centralized thing, then we had a discussion. Then he brought his points, and that is fair. Like that's his own opinion, which he thinks. So overall, I felt like we had a conversation, and here and there we have some different ideas, but that's fine. That's how system design works, like where people can have different ideas. So yeah, that's I think overall high level feedback from my side.
Yeah, thanks a lot, Aseem. I totally agree, yeah, with your feedback. That's very good. Thank you so much.
Yeah.
And I can share some of my observations. So, with respect to time and like the way Abhishek started, and mostly managing the time was also almost on time. So, except that at the end you actually spent few more minutes if we take 45 minutes clock, but I think it's okay. And in the beginning, I actually liked the way he was asking questions and he was trying to distinguish functional and non-functional, and thinking about the rate limiter and stuff. And I think the moment where I think I deviated, I mean, like which I didn't like because the high level design, I think it's because of the approach that he chose, which is not in terms of my alignment. If I was interviewer, I might have deviated you from that approach. But I think, yeah, as Asim said, it's depends on the approach actually, what he has in mind or what interview has in mind. So, and yeah, especially like when you're choosing the approaches, I don't know if you have explained enough of choosing a single centralized API rate limiter versus having having a throttling component in each of the application service component. So I think you went ahead with the application service based throttling, right? Having in each of the servers.
Yeah.
Okay. Yeah. So versus having a centralized, but like my view was more of a centralized.
Okay.
So yeah, I mean, like I'm okay. I mean, like as long as you made your justification there. Maybe I was looking at the charts around the time. I didn't pay close attention, but like my approach was more towards that centralized one. And then yeah, and most rate limiters I think which I see in the market, I think are more of centralized nature than the way you explained, I think. So but yeah, but the main thing is like in system design, why you choose certain approach, like as long as you make certain justification, I think you are trying to do that. But yeah, I didn't fully listen, but like as long as you discuss both approaches and choose which one makes sense before jumping onto in detail for that approach, at least like a high level discussing of both approaches generally makes sense.
Yeah.
Mm.
Naga, one thing I don't know if I should I should interrupt, but I think what I wanted to say is that I don't want like the problem I see with centralized is that centralized node can also not handle 1 million requests per second. I have to do some processing, and that processing can also not happen in one centralized node. So again,
Yeah, agree.
yeah,
But like, yeah.
So yeah.
So correct me if I'm wrong, sorry to interrupt. When we say centralized, it means that this centralized service and that service can be distributed to handle the 1 million requests
Yes,
per second.
yes,
Right.
yes.
That's what you're trying to communicate here, like a centralized service, which is even distributed
Which is
again.
still distributed again. Yes,
Yeah.
correct.
Yeah.
So it's not just a single point of failure at any point. So you have multiple machines, like, yeah. So
Okay.
even
Yeah.
if it's centralized, yeah.
Yeah. Actually, yeah.
One primary. So, and since they don't do much job other than just verifying and forwarding, like not much logic, so it's generally quicker. So,
Yeah.
and, yeah, I think overall, like you discussed some algorithms. I don't know if you have discussed both soft and hard limits. I think you did discuss those. And there is a kind of windows. I think you explained the approach. I don't know if it was a fixed window or a sliding window approach that you explained. Yeah, and I think your overall approach was fine, except that, like, since because of the approach is where I differ. I mean, like, that's okay. I mean, like, as long as you make kind of justifications. The main, I think, in system design is main about reasoning. It could happen that interviewer might like it or not, but like it's you have to explain why you are choosing certain approach versus the other, and just to explain your thought process behind it. So that is important than the actual decision, I think. So yeah, that's my observation. Like others can feel free to. I mean,
Yeah, I have a question here.
Nitesh.
From your experience, what you just mentioned, I mean, you have seen the centralized services. I mean, when you create a centralized service, right? You have to think of a deployment model. You have to think of the resources where um, and lot many things. Whenever you plan to deploy something as a new service, right? In this current model, what I liked from Abhishek is he chose something that is running within the application server. Maybe had it be me, I might have chosen a library which can run within the service itself, where you can call from the library, and the additional, instead of having an additional full-flown service itself, maybe I could have chosen a one in-memory database where all these nodes can a good in-memory database where the request comes and then it update the in-memory, which is fast enough, and then any node.
Yeah, I think mainly the reason for centralized or like not having in the application servers, the main weightage is basically why we need rate limiters. For example, as a bad client, I want to bring down your revenue, or I want to get a bad name for your company. So if I'm one of the clients and if I'm not rate limited, I can easily try to identify the pattern, like how it goes to multiple application servers. So I can just increase, like it's a DDoS attack, right? Like, so I continuously keep hitting and my main target is to bring the application servers down as quick as possible, and cost downgrade of the service, or some
Correct.
malintention. So if the request
Correct.
is going to application servers, then the network, you are already overloading the capacity, right?
Yeah, but what I understood from this point, actually, um, from this API rate delimiter or something, I think of as a functionality, and then DDoS attack and all that. That's my understanding, though I might be wrong here. Well, I thought that was not in this scope. That those DDoS attack can be handled before even load balancer.
No, but I mean, like, but how? I mean, like, it depends. Like, if normally load balancers or API gateways have this inbuilt capability.
Yeah.
Like, but the rate limiting is one of the, or throttling, we say, is one of the intentions to prevent this DDoS attacks.
Yeah. So I thought of this problem. I mean, I was not able to think of any other way of any business way or any I was not able to relate it to any project or something here and there, except like Netflix or Prime, or where users are consuming the API to read the video content or something, or even YouTube. How many parallel streams you can have? But that's is that something that, Aseem, that you were asking? This is on the same terms, like premium user can have 5 streams and then a regular user can have 1 stream or something like that.
So this could go any yeah, it could be like a like the example you mentioned, or it could be like a, I think in between Abhishek also mentioned, like credit card, we only allow 3 failed transactions and then we want to limit it for 30 minutes. And or it could be something else that I have a logged in users and anonymous users. I don't want anonymous users to use that many requests. I want my logged in users get the most quota. And if anonymous users are requesting, it will result them as a 429, too many requests. So I'm okay to stop my anonymous users coming in. So it could apply it in different ways.
I think one more scenario everyone will relate to is on lead code. We see, right, that if you're not premium customer, if you submit code multiple times,
Yeah.
Or if you think about Google APIs or anything, right, which you have
Yes.
purchased, one user should not be able to hit the system so much that it will start having the performance impacted for the other users.
Yeah. So have anybody seen an S3? I get this 429, too many requests. If I try,
Even we get it for Azure as well. Correct.
Yeah.
Sorry to go back with the same discussion that we had, like, if we use as library, then the problem is that, let's say you're trying to, let's say there are three instances running, and in all the instances we're using our library. So how would you coordinate, how many requests that actually has been served at each application server? I mean, because that's the problem I'm trying to solve. Every second a user can actually send 10 requests to 3 of the application servers. So it means 30 requests. The quota is 10. So how would we actually deal with it? Because it's
there are 2 ways to solve this problem that I think of at this moment. Is whenever a request is made, the first successful, so along with the 3 nodes, which is a library, library, it's just a DLL consumed by the service, and then behind the scene there is a database also, which I think of in-memory database, which is a fast enough, not writing a transaction into the memory, so that the communication can be fast. So all these nodes will transact with the in-memory database to see how many users are and that database will you will update those values. Instead of keeping in memory in that application server, you will keep that information.
Totally understand what you're trying to say. But now imagine when you talk about in-memory database, so it can be Redis, it can be Memcache. So you're actually making a network calls by the all three of the application server and trying to coordinate all the counts for each user ID whatsoever. It's better. Like now it clearly makes sense. It's better to take that thing out of the picture and have a centralized system where you're just one network call rather than dealing with all the network calls from each of the application server.
But in that scenario also, the centralized one, network call is still there, right?
Yeah, so it's there, but now here you're dealing with the, let's say, 10 application server, 10 network calls, because you have to manage the counts of each user at each of the application server, as in how many requests can be served. Like 10 network calls add on to, so as we cannot scale it. And now
I'm not saying 10. What I'm saying is when an application server has made a successful request, it will update the database somewhere. When the next request will come from a different node, and that will make a network call to the database only. And then it will get the state is there, and then it will reject it from there. There is no cross AS communication. And I'm not talking about the same what initially Abhishek suggested, the broadcasting. I'm saying the communication is only with the database. From the AS to database, no cross AS.
So you mean to say that every application, so there are 2 things. Every application, every request will actually go to a database, will read the count, and will decide whether to serve or not to serve. Am I right?
And update also. I mean,
update. So that's something you're saying. Okay.
Yeah.
Okay.
That's one way of doing. I have another way or think of is probably we have n number of application servers, right? As soon as an application servers light up, your machine name, it can register in the database, additional similar database. It can register that these machines are active as a request, and then those machines, there can be an hashing done on the user or the whatever identity that we treat. And hashing can, from the database, we can get which machine is responsible for maintaining the count of this particular identity.
But that's more of that's not scalable, because that's more like your that stateful system. Ideally, we should be avoiding that. I mean, we should definitely avoid stateful thing over here, because we are trying to now connect machine to the user session, because this user request will go to this particular application server, which I think it's not scalable, because one machine goes down, you bring it up in between where those users will go.
Yeah, those yes, that's the drawback of that problem. Yes, I agree with.
Another thing I want to add is that like if you are making a request to a centralized service, then every time you have to decide, you are making a call to external service request, and then you are waiting for the response, and then you can finally decide. But if it is within your application, you are not creating any additional request. Like you are not waiting for the response. So you are asynchronously sending broadcasting, but you are not waiting for the response. You can just, whatever you have in your data, based on that, you can decide whether you can serve this request or not.
When you say broadcasting, broadcasting to where?
All the machines.
All the machines.
So, okay.
So yeah, ideally
for the response, you can just broadcast and you are done. I mean, you can actually first decide whether you want to throttle or not, and then you can broadcast. Like that could be asynchronous.
The only I think it's more or less probably a difference between maybe a trade-off. What is more important? Like, is it that?
correct. So yeah, that is something that we need to check. Yeah, so it depends, like why we really needed a rate limiter. Is it to avoid excessive uses of application server resources, or is it just to make sure that client is not exceeding? I mean, like so typically this rate limiters, even if it's whether it's centralized or not, how it's implemented or not, they are supposed to be highly available and very latency sensitive, which means that it should execute within sub-milliseconds.
Correct.
So it should make a decision within that fast. That's why like they can be part of whether this load balancers or API gateways or whatever. So because like they don't take a lot of time, right? So they just it's like it just behaves like one hop with extra few sub milliseconds or nanoseconds. It makes quick decisions. So mostly they use in memory. Even the rate limiter service, yeah, they depend on in memory, so they don't need to go on any other databases or like. So I think they should be able to make decision pretty quick, because the user ID or client IP address is already there in the headers. They don't need to look into the parse full body to determine and do any logic to really do a rate limit. And the algorithms also are pretty fast, like if you use hash maps and stuff to identify, and they're all in memory, right? So it won't take a lot of time. So
that's fine.
And the problem with in-memory database is like when you read the count from the memory, then at the same time a lot of app server also read the same count, and everybody increment the count at the same time. Then now it become
so
inaccurate.
yeah, the trade-off is like if you have centralized one, you already know all the counts with respect to the rate limiter service itself as hold of how many users have how many. But if it was going to application servers throttling, then like all of the limits are now aggregated across all the application servers to determine whether the client actually exceeded the limit or not. That, yeah. So
in my understanding, so we should filter out the request far way before the application. Means invalid request should not even go to the application. So
Yeah,
we
yeah, I
can
mean, like
introduce.
that's, yeah,
Yeah.
that was my
because because
understanding as well.
because what because what will happen is that if suppose there are lots of requests and though application is using the library or calling the database, if that part goes down, whole your application will go down, right?
Mhm.
So I think we can, as Naga suggested, we can go with the centralized component and we can keep that as a behind the front end load balancer. And once the that centralized component give the request is fine, then we can route that request to the application load balancer.
Just correct me if I'm wrong. So what if I look at the other systems that actually built, so there are two kind of rate limiters. One is which actually, uh, you know, completely block your requests at the edge itself, or there are some rate limiters that we use for our inter service communication. Both ways there are two kind of rate limiter
Yes, yes,
that
yeah,
we
yeah,
use
correct,
in,
correct.
in an actually real scenario.
Mhm.
One is the edge, where at the edge itself we kind of drop the request, and in between the service communication we use some sort of rate limiter. Let's say I am running my service internally, I don't care about other system, I don't want my service to go down, so I'll use some sort of rate limiter logic in my service. So that's where library comes into the picture. When you talk about the external edge,
Mhm.
that's where service rate limiter comes into the picture. So both components do exist at the moment, I mean, as of today. So it depends on what's the use case and which we want to use. So I think when we discussing this question at the beginning itself, we could have like maybe have a functional requirement as to what exactly is the use case. Are we trying to so that's something maybe we could have discussed.
Yeah,
uh,
yeah, I agree.
and
Yeah.
another thing that I feel that one important component is missing from this whole scenario is the metadata APIs of the rate of the configuration of your business rules. So for example, how would you actually onboard the content? How would you tell your rate limiter to actually, to how would you tell your rate limiter as to what is the business logic? For example, there should be some APIs exposed where you can actually uh, um, you know um, update your business logic, as in this user should have this many requests, because every user and every API key would have different requests. It cannot be like one rule. So there should be different metadata APIs which can be used to onboard your business rules.
Yeah, I agree. I mean, yeah.
I'm just asking, is it right or wrong? I mean, that's what I feel that. So
Yeah,
this component is
you are
also
right.
very,
You're
very
totally
important.
right. I mean, we discussed briefly, but probably we could have discussed in detail that. So this your business rules, right? That for each user, what is the count? You could have more information, and you're right. Like in this functional requirement, we need this another more APIs that to update those business rules, right?
Yeah, I mean, so one is that's more of a APIs that can be used by internal system or something like that. Update your rate limiter count, or update your anything. So something
Right.
like so some sort of metadata APIs apart from your system APIs.
Yeah.
But isn't that probably an out of scope of this design?
No, totally. So what I mean to say in the beginning of the question itself, we should have like clarified two things. What exactly the use case that rate limit is trying to achieve, whether it's a, edge, whether we are trying to limit all the requests at the edge, or whether we're trying to create rate limiter inside the service, which can protect your service. That's another thing. Or this also could have been discussed whether we want to have write some metadata APIs, because it's a different system altogether. So
And I
basically,
think
what we discuss is the read path, no,
yeah.
read path, and we should also be discussing the write path. How would we actually tell our rate limiter to, okay, these are the requests that you need to, these are requests that you can actually pass through. So it makes things easier when you discuss both the read and write path. Makes things more
I
clear.
think we discussed briefly that when the users will sign up or when he will update the business rules. But yeah, we could have gone in detail. But one thing I want to say is that yeah, now I think about it, it's a good point because initial about having a central system or an application server. Because I remember when I asked Aseem initially that what is the use case, he said that you want to build a generic service that anybody can use. So if we are building a generic service that anybody can use, then probably I should have gone with the design of a centralized one, not with the application service, so that anyone can use that API rate limiter.
And also what I'm now thinking about the broadcasting logic, because now this broadcasting logic, like, so for example, so that's like a concurrency problem that we have to solve. Because what happens, let's say you have 10 application server, all 10 applications that have got the request, and everyone's trying to broadcast to every other machine. So it makes it a little cumbersome and difficult to deal with. So
But that is a separate problem that can, so you are saying, so
it's like a very serious
standard for concurrency problem. So you will have to apply the locks.
Yeah. I mean, logs again. If you're for example, there are 10 application server, each has one request count left, and now let's say I send request to all 10 of them concurrently, all 10 will get served. That's for sure, because then you serve the request and you asynchronously try to update other processes running elsewhere, and that's what will defeat the purpose of rate limiter.
That's
Agree.
Good.
Yeah, that's a good point. Yes.
I mean, yeah, that's what I would think of apart from this discussion.
Anyone else has anything to add on or like?
Yeah, I had one question for Aseem, which actually I was asking to Nisha also. How would we take care of the DDoS attacks?
I think we're losing your voice. I don't know. Hello.
Well, I would like to comment here.
Obviously, cannot be detected. Yeah. Hello. Yeah. I was just asking.
Yeah, I think we are losing you.
How do we take care of the DDoS limiting in that context? Oh, okay.
Well, I can add something.
I'm just typing it.
The DDoS stuff is in general. This is not just a feature. It's something that is taken care by almost every service, and it's required everywhere. So, and this probably requirement is different than this is a functionality that we need to build where we can restrict a different user with a different number. DDoS is a separate problem altogether, and it is in general there are defined solutions, and they are generally handled separately before the load balancer itself, or as a part of.
So if I'm not wrong, when you talk about DDoS, so we can just have some sort of IP mechanism. If you're getting requests from one IP, one user agent, that's pretty much like 100 constantly. Let's say I've written some program which basically sends a request, HTTP request to one particular API endpoint from one IP, and that's pretty much of it. I think we can clearly block requests from that particular IP.
I see.
Am I making sense? Sorry, I mean, just that's what I thought of. I don't have
IP address is shared, right? IP address is shared among.
Yeah, basically, yeah. If you talk about even IP address, like it's kind of again rate limiting itself, right? Like you are blocking certain IP user from unnecessarily overloading your systems. So it's indirectly an API rate limiter based on IP address.
Okay, but just now somebody said that DDoS already been handled, but now let's go into detail how actually DDoS are implemented. What is the solution? I don't know.
Yeah, I think that's a different separate design discussion itself. But in general, as I was mentioning on chat as well, it is based on IP source port type of request, as Rajesh was mentioning, user agent, right? That would be one of the parameter type of request. That means what protocol is it for? It is for DNS, HTTP, and all that. So if there are so many requests coming in for the same thing over and over again in a very short time, then that is how it blocks.
So you're saying IP and the source port is the actual unique identity pair.
Just of the few parameters, there are much more.
So would you like to mention those parameters? What I can think of is user agent, let's say one browser or something.
User agent is like same, and IP address is also same across like multiple things. I think that would be something like MAC address.
So basically, it's called 5-tuple algorithm that is being used in load balancer as well, wherein so it includes like source IP, source port, destination IP, destination port, and I think the last one is protocol, if I remember correctly.
What do you mean by protocol?
Protocol means it's the request is for DNS or HTTP or something else, right?
So correct me. When you say DNS, request for DNS or HTTP, I mean, sorry, I couldn't understand this point.
So basically the request is for DNS, right? That would differ the way it looks like. Because there are the DDoS attacks for DNS as well. That is very common actually. So the web application firewall has to look at that as well in order to decide whether it should block it or not.
Oh, I get that. So correct me if I'm wrong. So when I type HTTP something, it connects to the DNS. So the protocol being used to communicate with the DNS is different. So that's what protocol you're mentioning here. Am I right?
Exactly. Yes, that's true.
Oh, okay, I get that. And are you aware of that protocol that we use?
We use for what? So it depends what kind of request you are making, right? So for example, if you are just browsing a website, the first thing that needs to be done is to resolve that IP, host to an IP. So that will be the DNS request first. Then there will be an HTTP request, HTTP or HTTPS, whatever.
I get that. Yeah, makes sense. Thank you.
As far as I know, I mean, we can't use the other things like a MAC address and these all, I mean, the source port, destination port. This will actually increase the memory at our end. So generally, if people are doing DDoS attacks, it will be based at the IP level itself. I mean, storing the file tuple itself increases the memory overhead as such. If it's a legitimate client, those clients are not legitimate as such. They can actually spoof the address, the ports as such. So generally, it's based on, the DDoS would be on IP itself. I mean, the legitimate clients will have a different IP address and they will have very few requests per second or something like that. But if it's a DDoS attack, it will bombard us with the requests from a fixed set of IPs. So, I mean, the IP is enough at the DDoS level.
But if let's say from one network, let's say from an office which has one ISP, so we'll only have one public IP, right? And if there is a
so the thing is, so in an office network or something like that, I mean, you will have constraints like the network bandwidth and these all. So generally,
what I'm trying to say is, so let's say somebody is trying to do a DDoS attack for DNS, for example, right? If somebody is genuinely sending a request for HTTP, why would you block it? But I agree, it might only be IP. I'm not too sure because file tuple algorithm load balancer uses that I know. I'm not exactly sure on what all parameters DDoS would be using, but I think it does look at these other parameters. I'll have to go back and check too. I'm not totally sure on that. Because, I don't see if somebody is doing a DNS DDoS attack, why would you block HTTP request, for example, right? So
I agree. I think port is also a very important factor here. On just when you cannot do anything. Source port is, I think it's important. Yeah.
Source port testing. I think
it's definitely important. I believe. Yeah.
And it's not like a very big information. It's just integer, right?
No, but that's fine. But at the end of the day, you're determining, from which application the request is being generated. If the source port is the same, we are pretty much sure that okay, this request is being generated from that particular application, and that is the bottleneck. So I think it's very important. I think this cannot be the thing for that. For DDoS.
Good.
Some background noise. I don't know, sir. Everyone mute except when they're speaking.
yeah, the thing is when you're doing an HTTP request or some other request, the application itself opens a random port, and the ports that can open on a single machine itself is 64K or something. So you can actually have a single IP with 64K combinations.
Oh, okay.
Yeah.
not all the parts will be usable, but still the number is a big from
I
one machine.
The source
I
machine would be using the source port would be ephemeral port, but at a time it will be one port only, right? But the destination port will be same, right? So if we see that from this IP and the source port, which could be same or different, if we are seeing the request for same thing over and over again, we would block it. I think, in my opinion, it should look at it, but I can go back and check. I'm not 100% sure on that.
Okay. So I think any other final comments?
I have a comment for Abhishek.
Uh-huh.
Overall, everything looked really great. Like the way he started, uh, getting the requirements and non-functional requirement, all those looked really good. Then he went with the approach he liked, and I was trying to see if he can give sliding window options and all the other options, how we can calculate the user ID count based on the timestamp and other things. But I think we ran out of time, so we couldn't get to those things. But yeah, I think sliding window was the keyword I was looking for, but I didn't get that. That's the only comment I have here. And the other thing is, I think Abhishek went with the he had his mind made up for the approach, and that's why every time he was just going back with the same approach again and again. So it's not bad. It happens in interview. Generally, we are always one-sided, and we don't listen to the interviewer that he's trying to give us some hint, like don't do this, don't go with this route, go with other route. But we don't listen. It's very very generic in the interview. So those are the comments I wanted to add.
Okay, thank you.
Yeah, thank you, Ash. I agree. I think I was a bit towards one side on few things. So one thing I know of is that this design of having it in application server, I was more inclined towards that. Is there anything else that I was more like I was not flexible?
Yeah, and the other thing is the sliding window keyword. That's the only thing I was looking forward. And then the third thing is, I think, as you mentioned earlier, like you have not written down in your non-functional requirement, like the service should be independent. Anyone can use it. If you had that requirement, you wouldn't have gone with the AS tech approach you were looking for, like everything on particular application server, right? So those things should be there. So when you are doing in your final round, when you are doing the verification, whether your model works or not, you could have like figured it out. Okay, now this thing is not working. I should have picked this approach over this approach.
Yeah. Right.
No, but I feel like it's okay. He has some solution in my mind, and in system design there is not like a good or right or wrong thing. So whatever he felt could be appropriate and fine. And even the library, I can use it anywhere. I can give it to someone who can use my library. So, but the only problem would be like it could be language dependent, or there could be other challenges. But I won't say that. Yeah, there could be concern, but that's what in system design I want to explore. What is his strength? What he feels, and yeah, and you are right. Like system design verification could be different in terms of this scenario, but I don't also want something what I know on top of him, rather than I want to know what he is doing, what he knows best of how to get best out of him.
True, agree with you. Yeah, I just wanted to say like these points. If you have like make a note, that will be really good. Like when you are deciding what approach you want to take, you can just pick based on the requirements. What are the requirements you have written down before?
And again, I think it's like the interviewer, right? In this case, Aseem is like wanted to explore more and see like what all things he's considering, or maybe sometimes interviewer wants you to go in one specific direction that he is looking for. So as long as you keep getting the feedback from the interviewer on whatever approach you are taking, that might be right.
Yeah, I agree with that, because when I asked him which approach you want to take, he told I won't say, okay. Otherwise, I could have told him, no, this does not meet my requirement. Please don't go with that. But I want to see what he is good in that. And then I told, it could be different in different interview, where interviewers say, hey, can we circle back on the requirements? Does it work in that way? So could be two different scenarios.
Yeah, I think this is kind of an approach what we can take. Yeah.
So one thing I want to add, Ash, about sliding window thing is, you are right about it, but so it's in the system design, like there are a lot of components. I don't know, Aseem can tell, but I brought up the problem with the fixed window, and then he stopped me there that it's fine. I agree that you know we can figure out the algorithm.
Okay.
Because like if we are just discussing about how to solve this problem itself, it could be a interview itself of an half hour or 45 minutes, that what is the best approach to solve this, probably, right? I don't.
Yeah, as an interviewer, if Aseem wanted to drill down more on algorithms, he could have done it, but I think he didn't choose that. So I think, I believe that's the reason Abhishek didn't spend time there.
Yeah, I just told that this is the problem with fixed window, and then I just stopped there. Now it's
okay.
on Aseem that he want to go further or not. Yeah.
Oh, okay. So you are just assuming like a fixed window. Okay.
Yeah.
Yeah, I think on the same lines, I agree. Like he did talk about the window, just he did not use that word, which is fine, right? So overall, I think it went fine. He did well. He collected the requirements, written those down, so it was good. The only thing is, I felt was Aseem was giving you hints. You could have taken those hints better. That's the only thing I have. Like even at the end, like maybe 5 minutes were left, he told if you could do it before the load balance run. So he was giving hints. You could just maybe see if you could change your approach based on those. But I think overall it was good.
Yeah. Still, but I don't know how to do it before load balancer, so I didn't have.
Yeah. I mean, like you should be comfortable on the approach that you are doing. I think that's what you did, which is good. I mean, like it's basically we should not hire the same like our people, right? Like we should have some people with different opinions, and like the main thing I think people sometimes I don't know if they don't expect certain approaches which they think is good, they might not I don't know make a higher decision, but like in general I think the approach that you followed is good, because you are giving reasoning of why you are choosing certain approach, so that like interviewer can make a judgment, right? Like I think that's what everyone normally expects. I think you're diagramming, I don't know if you're using iPad or something, but like the wordings and diagrams, everything was clear. So, and the approach was also clear. I mean, like the decisions of which approach you use. Generally, I think if I was an interviewer, then I would also given a hint that I'm expecting some other solution than this. See if you can and still convince that you are using this because of this. So, which is okay. Yeah.
Thank you.
That you were using for drawing, even I liked it.
Yeah, I mean, like I also like I don't know, I can't like that. I don't know which tool you're using.
It's not this app. This app is not good. You need the hardware. So actually, Surface, you need Surface Pen and like Surface laptop. If you have this app on your normal device, it will not work that great.
But what app is it? Is it Microsoft Drawing or what is it?
Whiteboard, Microsoft Whiteboard.
Okay, I think we are almost towards the end. Any?
So
Yeah,
yeah,
you can, I
I have
think,
one question
stop the
for
record.
I have one question for Aseem and Naga. I mean, so this is the first time I'm attending this session. So just want to understand. So as we go up the ladder, as in for senior software engineer, staff software engineer, that's it. This question comes up. So what is the expectation out of an interview? That what are the things that one should be covering? Because I'm sure when you give interview as C2 senior or staff, the same question can be just modeled into like a different thing altogether. So do you want to give insight about like, let's say you want to interview a staff engineer, what are the things you are expecting? Can you just tell me that?
Yeah, I mean, like each company will have certain evaluation factors, right? Like generally, I think recruiters generally tend to share how it's going to look and what kind of factors they normally evaluate, or like the kind of questions. So starting from, I think even the way you ask requirements and clarifications, and choosing the approaches, like are you listing all the approaches that you which are possible, and choosing the one which is which makes sense, like for that specific use case. And yeah, the solution is obviously expected for most um, levels, but I think the follow-up, how you decide the trade-offs and bottlenecks, I mean, like how you choose approaches, the reasoning, and whether you are considering the monitoring aspect and the failures, basically how you handle the failures. I mean, like basically the overall design, like with a normal software engineer versus senior or staff. So basically how your design can cope up the failures, and how it can be like like how you monitor, like there are many factors, like maybe monitoring is not an aspect for the regular junior engineers. All I'm looking is like whether he's asking some questions on the requirements phase and going with high level design and explaining some reasonable approach is okay. So, but like for a senior software, like discuss various approaches, and the trade-offs between multiple approaches, and why you are choosing certain approach. And maybe like even for a staff, like even discuss, I don't know, maybe more high level, like I mean, like apart from all of this, like monitoring, and maybe little more maturity in all of this aspect.
Okay.
I mean, like, yeah, I don't know if, I mean, like if anybody else wants to weigh in, that's also fine.
So let's say, I mean, if I have to give this interview, so what I would like to add about the stuff, for example, how would I run my distributed service? For example, I'll use, Kubernetes. How load balancer will actually determine those distributed service, or maybe, I'll have some sort of scheme, service registry from where it can actually pick it up and, hit my distributed API rate limiter. And then maybe defining a data model, clear-cut data model in your database, or maybe whether which database you want to use, Redis or anything, or memory, or how the network communication is happening. Rate limiter. How would you actually communicate with the rate limiter? Let's say HTTPI or any thrift service. So, like, if I add those details, that's what makes it like a interview for a senior engineer versus like a junior engineer.
Yes, definitely, like discussing all those aspects will definitely put you for a senior engineer, I think. But like again, it depends on company. Normally, if I think if they want to become interviewer, everyone normally will be given certain training in each of those companies where you're going for. So they will be given certain factors on which you will be evaluated. So basically, you will be looking for all those points. Those points could be like how much time you're spending on requirements, and whether you're distinguishing between functional, non-functional, and how many non-functional have you considered in your design, and whether your design is reasonable, or like, are you making some latency sensitive decisions, or like, are you thinking about the capacity estimations and sizing your databases accordingly, scaling accordingly. So, so all those factors will definitely be needed for seniors, I think.
I get that. So what I thought about it, might be wrong. Like for example, when Abhishek was trying to gather the requirements in the beginning, so like let's say a senior engineer wants to cover a lot of things, and that's why an engineer wants to save as much time as one can in the beginning itself, where things are obvious. So, example, let's say I know what a rate limiter is. I will just write the functional requirements like quickly, and just try to cover up non-functional requirements ASAP, so I have enough time left for me to discuss a lot of things to make it appear like a big interview. Does that can that be a factor between a senior engineer or staff engineer or decision engineer?
Yeah, even if you know what the system is, like the interviewer might have certain things in mind. Like, so it's good to clarify as you are listing the points in requirements, just clarify with the interviewer that this is what he is expecting. So, like, yeah, you are definitely expected to go faster than the junior engineer. Yeah.
So the thing is, I want to save as much time as I want to, so the way would be that the components which I am aware of, I should just, get through this very quickly and just have enough time for the discussion left, so that.
Yes. Yeah, you need to time box everything, because all you have is 45 minutes, and then there is some intro, and then at the end some time for questions. So only few companies have 1 hour slots. So, but most people only spend on 30 to 45 minutes of time on system design interview. So, your overall like requirements covering functional, non-functional, and capacity estimation, and discussing the APIs, and
Okay.
the high level design, and deep diving in one of the components that interviewer wants you to do, and at the end verify your design, discuss bottlenecks, trade-offs, and conclude. So all this you need to time box, so that like you can finish within those 40 minutes.
Okay, and just last question.
So I also want to add one.
Go ahead, Aseem.
So I also want to add, for example, by looking in this interview, I would consider Abhishek as a SD2 engineer, but it would be a stretch for me to take him as a senior engineer over here. And the reason here is I can say that, for example, I told like when I started, I would first because I could easily see he's a good coder. He's a good engineer who writes code every day, and he spoke about the libraries and other things. But some things which was quite obvious, like this is not his day-to-day job, like designing new features, or like it could be like some other senior engineer is doing, and he might be doing. Like it's just my personal observation, because things can be figured out from the interview. And the other thing is, for example, like if it's a person who's doing day-to-day thing, he will ask a lot of why question, like, hey, who is my customer? Why I should not do this? Why should I consider this thing? And other things. And it would be a really streamlined flow for that person. Like, okay, now let's go to high level. This would be my component. This would be my rule engine. This would be my database. Okay, let's touch base on database thing. So I think there the clarity of thoughts will be little different. The person who is doing the designing as part of like kind of his or her daily job. I think because somebody asked what could be distinction, I thought to share my thing. But again, Abhishek, not the personal. This is just again my observation, and it applies to even me.
Yeah, no, I agree. I have this question. So one question I have, and I don't understand, is that people, so I think Rajat was also talking about, is that what service I'm using the names. So I don't understand why names are important. So these are brands, right? So for every, like if you're using a queue, like Microsoft has their queue service, AWS has queue service, there are multiple third-party services have their queue service. So why do I want to invest my time in talking about the names? And probably I have my experience with some queue service, the interviewer might not have heard of that service. So that is something you can drill down and go deeper, that and whenever you are actually want to use queue, you can look in the market which service you want to, and actually that will also depend on a lot of business decisions, that which service is cheaper for you, what are the requirements. Where it's like a mobile phone you want to buy, so you have to
So
and see which one is the best price for you, right? So I don't know, like, and I have seen like a lot of people emphasizing on the names of this, of what exactly they're going to use, that if it's a cash, what cash company they're going to use. So one thing is
So
that
I want to add, Abhishek, I have a difference in opinion here. And again, this is my opinion. For example, before I am applying for a job and going for a company, for example, I'm going to a company, let's say XYZ, and I know it's easy to find out from the job description that they use the AWS a lot. And it's good to go through the technologies. If you know Azure, you can go through, okay, what are similar things Azure, AWS offers, and you're going to that company, the people are going to interview, and it's okay if you say, okay, I'm going to use a queue, but if it is a AWS world, it would be like a SQS. So it could be a bonus point, I feel, in that way. Because then people think, okay, this guy has this knowledge, I could bring him in and could leverage him easily. That's what, again, my opinion.
Okay, so Aseem, just one thing. For example, let's say I go ahead and plan to use, let's say, distribute API rate limiter, and I can always discuss, okay, I'll make a Docker image which can be run on the cloud as well, let's say in a Kubernetes engine, or maybe on-prem scheduler or something like that. So that's what makes it a more experienced interview.
Could be as soon as you going into in general mode, like you can say, okay, I can. So when I asked you that how you'll replicate, how you'll make it distributed, that time some other things can come into picture. Like, okay, it could be Dockerized. If I'm running it Dockerized, so different cloud vendors gives different solutions. It could be Kubernetes from AWS or Azure or Google, or like. I feel like don't need to go too much in depth and see how the interviewer is reacting. So that's why I think they tell, like, most of the times the system design interviews are good when you're doing on a whiteboard. You can feel the other person body language, whether that person is really wants to go in more into that, but it's up to us. If I would be there, I would try to make it generalized, like it could be Dockerized, and then can say, like, okay, different vendors provide different solutions around that.
Mm-hmm. Okay.
And then some people even ask, like, have you used it? Then you can say, yeah, I have used it in this way, and if you haven't used it, you can say, okay, I didn't use it, but I know it, and my sister team used it, so I have some idea.
Mm-hmm. Okay. Yeah, makes sense.
Rajat, I just want to add one point here. So when you are specific, like you are using Kubernetes word there.
I couldn't hear anything.
Aish, can you re-ask the question? I don't know who was asking. Okay, I think let me end the recording and maybe we can just chat after this for a few minutes.